to find the derivative of sine x using the limit definition, we need two special limits. The first one is the limit as h approaches 0 of sine h over h, which is equal to 1. The second one is the limit as h approaches 0 of cosine h minus 1 over h, which is equal to 0. We will also need the sine of the sum of two angles. Given two angles A and B, the sine of A plus B is equal to sine A cosine B plus sine B cosine A. Following the formula, sine x plus h, sine x plus h will be equal to sine x cosine h plus sine h cosine x. Using the limit definition, the derivative of sine x is really the limit as h approaches 0 of the difference quotient, which is sine x plus h minus sine x divided by h. We're going to expand sine x plus h, which is sine x cosine h, plus sine h cosine x. We'll keep everything else the way it is, minus sine x divided by h. Since the limit of a sum is equal to the sum of limit, this expression can be written as the limit as h approaches 0 of sine x cosine h, and then we're going to tack on negative sine x over h, plus the limit as h approaches 0 of sine h cosine x over h. Why? Because now what we can do is, for the first term, we can factor out sine x. So it's going to be the limit as h approaches 0 of sine x times cosine h minus 1 over h. For the second term, it's going to be the limit as h approaches 0. We can factor out cosine x times sine h over h. Now, an interesting idea is that sine x doesn't involve h. It doesn't matter what h becomes. Sine x will stay sine x. Therefore, we can bring it out. Sine x times the limit as h approaches 0 of cosine h minus 1 divided by h plus, same reasoning here for cosine x. It doesn't involve h. You can bring it out. Cosine x times the limit as h approaches 0 of sine h over h. Now we have our special limit. We can do the substitution. Sine x and the limit of cosine h minus 1 over h as h approaches 0 is 0. So sine x times 0 plus cosine x and the limit of sine x, the limit of sine h over h as h approaches 0 is 1. Therefore, our answer, our final answer is cosine x. In conclusion, the derivative of sine x is equal to cosine x.